Welcome to another ISO Backgrounders. In this session, we're going to talk about TCP/IP, which is the pivotal addressing method which has been used since the dawning of the internet. In our ISO model, it pretty much defines the network layer. As the network has grown, so has the complexity of the addressing methods. We'll talk about how, over time, we have evolved into a system that lets us send and receive messages to the billions of devices that are now all interconnected. In this session, we'll talk about the makeup of the IP address and how some significant adjustments have been made to it over the years. We'll talk about routers, the directory name server, IPv4, MAC addressing, and packet routing. Along the way, I'll touch upon some of the special use addresses and how the IP address can be used for geolocating. And along the way, I'll throw in IP masking, subnetting, ports, and firewalls. So let's get started. In 1981, the Internet Engineering Task Force, which was an international group, got together and established some IP standards. Now, this group had decided that we weren't going to make the same mistake we made with radio, in which every country sort of did its own thing and everybody was stomping on each other. And it was a big mess, that we needed to get this organized and we needed to have some international standards. So they set in motion creating an international standard for the internet. Now, they set out with the idea that there would be various categories, and the Class A was for large networks like countries and militaries and that kind of thing. And they allocated the first octant, or the first set of octants, from 1 to 128, about half of them. And that's all the half of the addresses that would be available. That's 6,777,216 addresses in total. Then we had to find a Class B, which would be for mid-sized places like corporations and telecommunication companies and that kind of things. And they allocated another set of octants from 128 to 191 as characterizing that group. The third group, of course, was all of the small companies. By the way, that divided into 16,000 some odd networks, each with 6,500 machines. The Class C for the small companies, they allocated the rest of them. And that ends up being 2 million networks, each having 256 addresses. Now, do you see anything wrong with that? Now, this was conceived of, like I say, when we were just getting started. There's about 30,000 computers hooked up at this point. And think about it. How many addresses do you need, and how many Class A addresses do you need just to service the United States? Just if you give everybody one address, there's 342 million of us. If we each had one address, what would you use it for? Your phone, your computer, TV? Could a company like Verizon or even an airline or whatever survive on a Class B address? Not even possible. And really, that's only 65,000 total addresses. Just ain't going to happen. So, along the way, by 1996, they had to make some modifications, and they came up with special purpose networks. They reserved certain banks. Of course, these were reserved early on, but certain banks were set aside for, they had to be used in sort of a group way. The 10.0.0.1 is what you can use to send your messages on the internet freely, and the 127 was actually sort of a message exchange place, but they also thought ahead and gave we the people 192.168 subnet. That's a class C, right? Um, and how many times have you typed in those numbers? You're familiar with them. That is reserved for internal networking only. And if it ever gets out, um, the routers are supposed to kill it. So you can't use that number on the internet proper. You can only use it on your internal network. You do masking and you send it out on this network. Now, in 1998, they introduced IPv6. And in this case, they took the MAC address, which is actually burned into each device. Each device has its own address. And they look like that. If you've seen them before, each device has its own address. And this address was then attached to the other standard. So IPv4, they attached IPv6. And we have the ability now to have addresses and then devices under addresses. And that expands the capability considerably. And then realizing that, there's no point in trying to allocate the class A's to countries, it just wasn't going to work. They reallocated class A's to do geopositioning. And so you actually have the routers organically creating a system where basically everybody has their own path to places, and you can actually geolocate things based on their IP address. Uh, so let's talk about IP routing for a minute. Now, in this case, we're depicting two networks, their internal addresses, and there's a router that is in charge of sending messages from one machine to another. You see that this is a network 0, and this is a network 120, and this is machine 3, and this is machine 5 on that network, and so on and so forth. You create a packet, and you put it on the wire, and it comes to here, and it decides where it needs to go, whether it goes back this way or it goes that way. And it then gets sent down this wire if it was addressed to, say, 120.13, and this packet picks it up. Now, the network cards on the computers or whatever sit there and in the days of really slow stuff, they just sat there and waited for stuff addressed for them and then accepted it and let everything else go. And so there's a little gate here that says this is for me or let this one go. And the address is there in the header record. Now, this here is an example of the header record, or this is now an example of the header record. And you can see that we have where it's going, where it came from, information that it picks up along the way. This is metadata, and this is the packet. So by way of example, I went through my junk mail and found a woman who seems to be a little lovelorn, and she's ended up in my junk mail folder. So what we need to do is go into our header record and look at what there is to see here. Now, we'll pick up this one, the sender IP, and this is part of the packet as we talked about before, and we can go to any number of websites. I use this one, what's my IP address, and you can simply paste in that address and see where it comes from. And in this case, it is Pakistan. So, this is one of those situations that long distance love, if anything, but this is an idea of, as you can see, in those upper 200 octants have been reallocated for geolocation. And this is an example of what you use them for. Still, there was a need for a lot more definition here. The local administrators, and again, this evolved before we set the standards, but evolved with the notion that you should probably have channels. And they ended up on a 4-digit number for those channels. And those are called ports. And these ports are used to simplify the communication. That email always goes on port 25, and database queries always go on 64 or something like that. Uh, and you set up all these channels, and thus both sides just know that the protocol and the language that they're going to be dealing with is contained because it's on their channel, and they can deal with it and let the rest of it go by. And that also has a backdoor effect that now there's literally 10,000 places that you can send things in and out of, and it helps a lot to do that and to mask things and keep the hackers guessing what you're doing. And there's even ways to move ports around and what have you. But uh, by this time, these 4-digit assignments were added to the address. Of course, on top of all of that is the notion that everybody hates to type these numbers and even try to remember them. And of course, once you get to IPv6, those numbers get really, really messy. Uh, it was much better to give them user friendly names. And so they created the directory name service, which is a bunch of machines out there that when they see a number, they convert it to text or the text assignment that you've given it. And it makes it user friendly that you can type in whatever language you want, and it converts it to the numbers for you. So I thought it'd be interesting, if you haven't looked at it, just to look at what goes into an address that you see every day. That first section, the HTTP, is a indication of the protocol that is being run, and it can be a file transfer, it can be mail, it can be any kind of service you can imagine. The HTTP is for hypertext, which is the name that goes with the information that gets sent over browsers. The S, when you see it, means that this is secure. The packets are encrypted, and you can't actually see them until they get to the browser and get interpreted there. And so if you see the S, that, and there's a lock in your box when they're also displayed, that says that secured sockets are actually in motion. And so if you want it to be secured, if it's a financial transaction, look for that little key or lock or whatever that indicates that this is a secured socket. The www was an indication of the World Wide Web, but it can be anything you want and includes uh, the option that the administrator can put machine names or other services and use it for their routing. So if you have 5 machines on, that you're doing web services with, you can make adjustments with that. But the doesn't have to be there. You see a lot of addresses that don't put anything there. But if you put something there, it adds to your ability to route it and make it more efficient. And then, of course, the actual name. And there's various places where you can sign up for a name and they give you a number, and that is your name, and people can find you based on that. Now, the .com and the various things that followed originally, there was org and gov and mil, and there was half a dozen of them. Now there's all kinds, but that was to indicate that the main routers in the sky could quickly segregate it into the services that, or the organizations that wanted it, and it was sort of a military thing anyway. They wanted their own stuff, and once it was on a .mil, they wanted to control security, and so that was a branch for them, and it becomes a quick and easy way to sort packets and get them moving to the right direction as part of the thing. And then, of course, with port we just talked about, there's 4 digits there that you then helps you navigate through the right port into the firewall to get into the network. And then you'll see that there's a question mark usually. And then anything after that is up to the whoever constructed the packet. So if you need to send a piece of information uh, over the network real quick and dirty, this is the place to put it. So that's a quick overview of TCP/IP, and I hope you come away with the notion that it's really a basic, simple idea that really is pivotal to the existence of the internet. But it had to expand, it had to grow. The dynamics of what happened to the internet, has created these needs to add these additional steps. And if you do get involved in these sorts of things, you'll find that you're really doing IPv6 and you're really working on a machine level, and the MAC address is the focus of what you're working on, because that's where it is these days. Now, if you're talking about what happens behind the ports, or what you do when you're talking to the PCs, you're talking about the session layer, which is above us. And when you're talking about the routers and you're talking about the wiring and how everything gets wired up, you're talking about the network layer, which is below us. We're the transport layer. And again, without the transport layer working the way it does, you have nothing. Uh, if you want to explore this more, there's a couple of things you could, play with. Get yourself into the command line, the black box that in whatever system you're in, and run an IP config. With that, you'll see the current state of your configuration. And of course, you probably see the 192.168 something because you're on a local network. But more or less now you're seeing all the MAC addresses, and those are the way things are being routed these days. Another thing to play with might be a trace route, and you would trace route to 8888, which is Google, and it'll actually tell you exactly how it got there, and how many steps it went through, how many routers it went through, and what their addresses were. And for fun, you can do it a second time. It'll probably go a different way, because that's what the web is about. So that's it. We'll talk to you next time.